So, text analytics computational operations includes text classification. This is turning text into numerical data, which allows analysts and researchers to run mathematical and statistical operations on data. So, the three big ones would be logistics regressions, decision trees, and clustering. Data classification. So, this is when you determine the right operations to run on the data that is being operated on. So, to do that, you first have to have the necessary classification of data stream based on the type of structure or lack thereof. So, in these examples, I have unstructured data, structured, and semi structured. And based on what information you have, you can classify it into one of these categories and then find out how you need to compute it. So performing a text analytics process in a data stream, this is when we transfer text into numbers to get rid of much noise and information as possible. We compare this process to transforming eggs and bacon into an instant breakfast. The function is not the same, or the function is the same, but really the taste is not. So the four ways you can do this is through text mining, source identification, text phrasing and filtering, and then text transformation. And go through and look at the elements based on what quadrant it is in. So, some additional computation operations would be clustering. Clustering is when you organize text data into groupings called clusters and then connect the dots, creating meaning out of the data that is grouped. So, the first one would be nominal. And nominals are values that are not numerically related or have no fixed scale. So, for example, the textbook says that northeast equals 100, Midwest 200, Southeast 300, Northwest 400. Ordinal is numerical values that appear not to be related, and then continuous is values that are numerical and have a fixed scale, and can be interval and or ratio based. Then you can perform a topic analysis, which words are grouped into clusters that represent specific topics that are contained in a document. Topic clusters can get sorted and ranked once they are identified. All right. Depending on whether the researcher or analyst is trying to accomplish something, anyone can use a combination of these classification models mentioned in this chapter. So, discriminant analysis. This is used to classify a text into clearly defined groups using statistical models. Logistics regression is a discriminant analysis but works better with data that doesn't clearly fit into any category. Classification trees are a form of partitioning, organizing, and a space and are hierarchical in some ways like ontologies and uses if-then rules. So like if this happens, then this happens. Bayesian networks represent probabilistic relationships between a set of values and outcomes. So, for example, given a condition, the network can be used to compute the probabilities of presence of various weather patterns. And then custom classifiers. They are used when no other common way of classifying information is sufficient into classifying the information for a task. In this case, creating a custom classification model makes the most sense. Visual information is much easier to absorb than a text. We've talked about this previously. So many algorithms discussed in this chapter are adapted into using a visual, like a photo, a video, or streaming live. Software can be decoded into basic emotions via text analytics with differing accuracy. So using images and video streams, Emotion is one company that is the forefront of visual emotion tracking, and it was acquired by Apple, go figure, in 2015. The visual analytics space is very dynamic, and there's always going to be new offerings. Natural Common Processing, or NLP, is a field of computer science and artificial intelligence that focuses on interactions between computer and human language. The examples of NLP applications would be like Siri and Google Now. I'm more familiar with Siri. I think Siri is one of the coolest inventions that I've ever used. I use it all the time, and I think I just like kind of take that one for granted. Information extraction, extracting structured information from unstructured and or semi-structured data, such as text documents and web pages. Named entity recognition. This is locating and classifying elements from text into predefined categories like names of people, organizations, or places. And then corpus. This is a large collection of documents used to infer or validate grammatical rules, perform statistical analysis, and test hypotheses. Sediment analysis. This uses the natural language processing to extract additional information from a piece of text. Disambiguation is identifying the meaning of a word in a context using computational means or software. For example, using or developing an algorithm to determine whether the reference apple is verbatim or is it referring to the company. A bag of words. This is commonly used in a model of a text classification. A text or sentence or document is represented as a bag of words with order and word frequency used as a feature for training a classifier. Explicit semantic analysis. This is the understanding of the meaning that a text verbatim through a combination of concepts found in that text. So text and analytics best work when they're only like clear, defined problems that can add value. They decide on what's important and work on what is not. Be prepared to invest a lot of time and money in preparing data for the analysis than initially planned, because a lot of times it's unstructured data you're working with. Going for the simplest approach that explains what is important. So like, is it applied to data sets, algorithms, or clustering approaches? And then faulty analysis leads to faulty conclusions. So text analytics issues prevent its widespread adoption. Raw data is not normally useful information unless it is cleaned and organized first. Unless there is a compelling reason to gather and study the data will usually not be collected or examined. Analytics software or text analytics software requires a significant investment in time and resources. There may be a need to hire additional people to deal with these resources based on how deep the text is. Even top text analytic researchers cannot program machines correctly, tag content in a document 100% of the time. However, a lot of the information alone will not be helpful until the data is filtered, cleaned, organized, examined, analyzed in a specific question to connect the business goals. And the authors conclude that the biggest issue for text analytics isn't with the tools, but it may be the way that those are unaware about their limitations. Sediment analysis issues. The confusion over a number of emotions in an analysis. So emotions are not as standard across different sediment analysis software. Some vendors think that across different sediment analysis, like there are 6 basic emotions, which is love, joy, sadness, anger, fear. Others think that there are 8 to 16 emotions, which might work better depending on the case. So depending on what emotion set you use, may be more important. No one really knows for sure the best solution given a problem, but best trying to couple and seeing which one works better. Opinions cannot accurately be extracted. Opinion mining runs into common issues. Classifying a document or a sentence as positive or negative emotions does not add much value to an analysis if we cannot tell what the opinion holder feels positive or negatively about. So ways to overcome sediment analysis limitations. Aspect and entity analysis. This is one way to compensate for sediment and emotional analysis limitations is by performing aspects of analysis that are presumed targeting in a text being analyzed before applying emotions or sediment to the sentence. So when the software can determine the opinion holder, the opinion and the target in the sentence, then the sediment and the emotion will be much more helpful and add value to the analysis. Geolocation analysis. Most social media verbatims provide location information, which can be determined down to the block level, so like the latitude and longitude coordinates. Instagram supplies a lot of geodata, and it's easy to collect and decode along with their images. In addition, they will tell the identity to the almost always identifiable, along with their other postings that can tell analysis what the identifier holds values and likes. So how to choose a text analytics solution. Determine if knowing more about something is going to make it meaningful difference in the impact of the organization may take. If yes, then proceed with the text analysis, and if no, why would you waste your time? Determine the budget. If you have some free tools available, use it, but a serious effort in text analysis probably will rule out free or low costing software. The data can be analyzed, which may limit which platform tool chooses at choice, as Not all platforms process and file format types the same. And then determine how data cleaning or reorganizing is going to be needed to make sense of the data. So, however, until an exploratory project is undertaken, it will be hard to know if the data cleaning is required or expected. So, in summary, in this chapter, we looked at text analytics and how specialized branches, computation science is used to mine large amounts of textual material. Text analytics uses algorithms and statistical methods to turn text into numbers so that we can operate potentially doing probabilistic and predictive analysis. The algorithms and statistics used in text analytics are applied to so many domains of science and simply customized for text analysis when applied to a text corpus or visual corpus of data. And then most organizations do not utilize text analytics because they're unaware of the need for it or how to use it. And the main reason why it's not employed in more than often, there is also a higher stickier shock in using analytics approach, but it deters many organizations, so they may not have the resources or defined business needs to use it. So, as you finish this chapter, reading the chapter and looking through the PowerPoints, I want you to go through these question review for Chapter 10. What is text analytics? Why is it useful? Differentiate the static and dynamic social media text. Discuss different social media texts. Explain the 4 purposes of social media text analytics. And explain the common social media text analytics steps. So, go through these questions and really just get a good understanding about where you might need more help, if you need to contact me on this information, or if you have a great understanding of text analytics and algorithms. I look forward to hearing from you, and I will talk to you soon.